By weight, the average person is over 250,000 times heavier than a typical spider. However, these small arachnids continue to terrify many. This here in my hand is Lucy. She's a golden orb weaver spider, common all across Australia as well as parts of New Caledonia and Papua New Guinea. As part of her biology, she builds incredibly complex webs, allowing her to catch prey, keeping them out of our hair while we're outdoors.
Some spiders actively hunt and pounce on their prey, while others sit and wait for their prey to fall victim to their elegant traps, as webs. Web building is an incredibly intricate and innate behaviour in weaving spiders, thought to have evolved in a co-evolutionary arms race between predator and prey, when many insects gained the ability to fly. All webs follow a meticulous design and take a spider approximately 3,000 steps to construct. That's quite a lot of work for one dinner. Prey become entangled in the spider's web, where the spider then makes a meal of it. The building of the spider's next web is actually influenced by its feeding success. Spiders that successfully detect, capture, and ingest their prey will then go on to rebuild their web using less silk and have a smaller capture area than the previous web, putting less energetic investment into the subsequent feeding. A spider's web is constructed of silk, a material packed with protein, being stronger than steel pound for pound. Orb weavers typically remake their webs daily, regardless of feeding success or damage, and the construction of these large webs require considerable amounts of protein. In an effort to conserve this protein, the spider will actually eat the silk from the old web, recycling and reusing this protein.
The sole purpose of a spider's web is for predation, and ultimately feeding. Orb weaver's prey includes many flying insects such as flies, mosquitoes, and moths. But Lucy here can be seen eating a lab cricket. These prey become trapped in webs due to compounds known as vasoelastic solids. These compounds are incredibly sticky and are currently being studied to create synthetic versions. When their prey is caught, the spider quickly injects it full of a toxic neurovenom, preventing the insect from escaping while the spider wraps it in a cocoon of silk. Cocooning insects ensures that prey not killed by the venom cannot struggle or escape the web, while also allowing the spider to consume the prey later if it is recently fed.
So how are spiders adapting and evolving with today's ever-growing population and expanding cities? Current research by the Jones Lab indicates that spiders are actually using urban light pollution to their advantage. What's yet to be uncovered though is the exact colour of light that the prey is attracted to, and whether the spider has been clever enough to work this out.